A recursive function is a function that calls itself. Here I have a working copy of recursivefactorial.cpp from chapter 2 of the exercise files. And this is a function that computes a factorial. And a factorial function computes the value of n factorial as n times n minus 1 times n minus 2 all the way down to 1. Or, if you notice from that function, n factorial is equal to n times n minus 1 factorial. And so we're using that definition here by returning, first it checks if n is less than 2, then it returns 1. And otherwise, it returns the value of itself with the parameter of n minus 1 times itself. So, in other words, n factorial equals n times n minus 1 factorial. So when we build and run, we notice we're running it with a value of 7, and we get the result of 5,040. If we run it with the value of 10, you notice we get a much larger number, and if we run it with 5, we should get 120. So this is a recursive function. In other words, it's a function that calls itself. So a recursive function can use a lot of resources. For every recursive function call, memory is allocated for the parameters, for any local variables, for the return value, and for other overhead that you might have in your function. And all of this is allocated on the stack, which means that it's very possible to overrun your stack and create a security vulnerability. A loop is often a more efficient way to do something like this. And in fact, even with a factorial, the recursive factorial function is a standard way of demonstrating recursion in programming, and yet a loop is a more efficient way to do this. And so I'm going to leave it as an assignment for you to create a factorial function that uses a loop instead of recursion, and feel free to contact me on Twitter at Bill Weinman with your result. So C++ supports recursive functions, but you should be careful. For problems that may require a lot of iterations, recursion can quickly use up a lot of resources, which can easily create buffer overflow related security vulnerabilities. It's often better to find a different looping solution.